Imagine you're walking down the street, checking your phone, breathing, thinking, existing, business as usual. And then, without warning, the universe ends. No explosion, no dramatic countdown, no panicked scientists in lab coats waving their arms, just nothing. Physics flips a switch. Reality itself switches off. Not just for you or your city or your galaxy, but everywhere, instantly. No one left to notice, no one left to ask, what just happened? This isn't some cosmic horror story. It's not even science fiction. It's one of the real ways our universe could end. Not with a bang, not with a whimper, but with a silent, expanding bubble of absolutely nothing, racing at the speed of light, erasing everything it touches. It's called vacuum decay, and it's already written into the laws of physics. To understand this cosmic self-destruct button, we first have to grapple with the most deceptive concept in all of physics: nothing. Is it a true perfect void, some infinite cosmic silence, or just the most misleading word in our vocabulary? If you ask a philosopher, nothing is the absolute absence of everything: matter, energy, even the laws of physics. But if you ask a quantum physicist, well, you'll get a look somewhere between pity and delight, because in quantum field theory, nothing is suspiciously busy. Even if you strip the universe bare, every planet, every star, every last atom, space itself would refuse to sit still. Quantum fields fill every inch of the universe, even when there's nothing there. The vacuum isn't empty. It's teeming with invisible fields, each humming along at their own preferred frequency. And every so often, these fields get restless. Particles flicker into existence, then vanish in the blink of a quantum eye. Virtual particles, ghostly ripples, nature's static. But every field wants to rest at its lowest energy, a spot called its vacuum state. Picture a marble rolling on a landscape of hills and valleys. Eventually, it settles in a dip, happy as can be. But what if, just out of sight, there's a deeper valley? That's the trap. What looks like rock-solid nothing might only be a temporary lull, a false vacuum. And this isn't just poetic license. According to the best data from CERN, the vacuum we're living in, the very stage of reality, is probably not the deepest valley. That's right, space, as solid and permanent as it seems, might be just a holding pattern. So, should we be worried? Well, the good news is that the barrier separating our reality from that final true nothingness is vast. Calculations estimate it would take, on average, somewhere between 10 to the power of 110 to the power of 800 years for a random quantum fluctuation to push us over the edge. That's a number so large, the entire age of the universe so far wouldn't even register as a rounding error. So you can probably cancel your apocalypse bunker. But the fact remains, the trapdoor is real. The laws of physics allow for it, and it leaves us with an unsettling truth. Nothing is the most unstable thing in the universe. So, what keeps us from falling? And what happens if one day something gives us a push? So how can the very thing that gives our universe substance also be its greatest weakness? The answer lies with the Higgs field, and it has turned our existence into a cosmic cliffhanger. The Higgs isn't some distant star or mystical particle. It's a quantum field, an invisible ocean that fills every inch of the universe. Every second, it's giving mass to every fundamental particle you've ever heard of, and a few you haven't. Without the Higgs, there'd be no atoms, no chemistry, no planets, no you. The universe would be a massless, featureless soup. The great cosmic irony is that the field responsible for building everything we see is itself built on unstable ground. But here's the cosmic twist. The Higgs field is like a game of quantum musical chairs. It prefers a certain value, a setting that gives our universe its structure. But thanks to quantum mechanics and a meddlesome friend called the top quark, the Higgs potential isn't just a nice, smooth valley. Zoom out far enough and there's a steep drop, a hidden, lower energy abyss lurking in the math. If the universe ever slips into it, the rules of reality change. Instantly, no going back. But why are the Higgs and top quark such a dangerous duo? Imagine two cosmic engineers bickering over the blueprint for existence. The Higgs boson, with its mass of 125 GeV, is desperately trying to keep the universe stable, holding the ground beneath our feet. But the top quark, massive and rowdy at 173 GeV, keeps tugging at the foundation, straining to drag the whole structure into the abyss. Think of it like a cosmic tug-of-war. The mass of the Higgs boson works to keep our valley stable, but the immense mass of the top quark is constantly trying to pull reality down into a lower state. The result? A universe balanced on the knife edge between stability and oblivion. And right now, according to the best calculations, we're parked squarely in the metastable zone. Not doomed to collapse, but not guaranteed to last either. Our cosmic address is quite literally precariously close to the edge. Here's the punchline. If the numbers were just a little different, if the Higgs were slightly heavier or the top quark a smidge lighter, the universe might be truly stable. And while that sounds safer, some physicists theorize that a perfectly stable universe might have collapsed back in on itself just after the Big Bang. Our universe's slight imperfection, its metastability, might be the very reason it was able to expand and create galaxies in the first place. We didn't just draw the short straw, we drew the interesting one, the one that allows for existence but with a deadline. So the universe is perched on a razor's edge, but what could actually push us over? Let's start with the simplest answer. Sometimes the universe doesn't need a villain, it just slips. This is quantum tunneling. In the quantum world, a barrier isn't a solid wall, it's just a probability. And given enough time, even the most unlikely dice roll comes up. All it takes is for the universe to tunnel right through the barrier that keeps us safe. A tiny bubble of true vacuum could pop into existence. No warning, no cause, just sheer quantum mischief. If it happens, that bubble expands at nearly the speed of light, erasing everything in its path. No time for regrets, not even time for one last meme. But maybe you're wondering, could something cause the universe to trip? Physicists have asked the same question, usually after a sleepless night or two. First suspect, black holes. Not the friendly galaxy-sized ones. We're talking about tiny, ancient, evaporating black holes. Primordial leftovers from the early universe. As they vanish in a final flash, they create energy densities so extreme, some calculations suggest they might trigger vacuum decay. Are there any out there? No one knows. Maybe they all winked out eons ago. Or maybe one's dying right now, somewhere in the cosmic dark. Second suspect, us. Whenever humans build something big and loud, we worry just a little bit. The Large Hadron Collider? Perfect tabloid fodder. Scientists create universe-destroying black hole film at 11. To put this in perspective, the most powerful cosmic rays that strike our atmosphere carry 100 million times more energy than the particles we can accelerate in the LHC. Nature has been running this experiment for billions of years, right above our heads. If it were that easy to push the button, it would have been pushed long ago. So don't worry, our best machines are cosmic pea shooters, not doomsday devices. But what about a super advanced civilization? Building colliders 1,000,000 times more powerful than anything we can imagine. Could a civilization advanced enough to build such a machine accidentally press the cosmic self-destruct button? Perhaps. Some have even wondered if this is a great filter, a reason we don't see galaxies teeming with ancient empires. But any species that reaches that level of technology will face more immediate, predictable threats long before they have to worry about the universe's warranty expiring. And then there's the third option. Something we haven't even dreamed up yet. A new law of physics we haven't discovered. An exotic particle left over from the Big Bang. Or perhaps a twist hiding in the nature of dark energy itself. After all, if the energy of the vacuum can change over time, so can its stability. We know enough to be nervous and not nearly enough to feel safe. So the real answer? The universe could slip quietly on its own after uncountable eons. Or maybe, just maybe, something gives it a shove. And we'll never know which it was, because when the end comes, it'll be the last story this universe ever tells. So now you know. Our universe, for all its structure and certainty, might just be living on borrowed time, a cosmic fluke, balanced on a quantum edge. The vacuum that builds stars and galaxies could one day unbuild everything. No warning, no sign, no reason to expect tomorrow will be anything like today. Maybe that sounds terrifying. Maybe it sounds freeing. If you knew the universe was only temporarily stable, that reality could, in theory, unravel without warning. Would it change the way you'd live? Would you chase every chance, every joy just a little harder? Or would you shrug it off, reasoning that nothing, not even the end of physics, can be helped? And what about the search for truth? Should we keep poking, prodding, and measuring the vacuum even if we risk learning something that changes everything? Or is it better to leave some mysteries unexamined? Let us know in the comments below. Would you want to know if our universe is temporary, or is blissful ignorance the way to go? If you could ask the universe one question, knowing you might not like the answer, what would it be? Thanks for spending some of your borrowed time with us. If you found this journey as strange and unsettling as we did, subscribe for more stories about the universe's wildest mysteries. And remember, if this video ever just cuts off, well, now you know what might have happened.